Hello guys, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and today I'm going to solve a Sudoku variant called Windmill, and this was created by Lavaloid. The Sudoku has been taken from CTC Discord server and the link to solve is given in the description of the video. Please do give it a try and come back and watch the video. This is not going to be a live solve. I just completed the Sudoku previously, so I exactly remember how this Sudoku works. It's really an interesting one and I thought it would be excellent for a video. Hope you guys enjoy watching me solve this Sudoku. So let us go into the rules now. Each row, column and box has digits from 1 to 9 without repetitions, and in this line there is a windmill kind of shape you can see, right? And that's why it's titled the windmill. So in this line, adjacent digits must sum up to a prime number, right? So for example, if you consider these two cells, these are adjacent on the line, or even these two cells, any two adjacent digits on the line, if you add them together, they must sum up to a prime number. And by prime, the only possible combinations are from 3 to 17, 3, 5, 7, 11, 13 or 17. You can't have anything less than that or anything more than 17. So which means the first thing to notice is when you consider two cells, to get a prime sum, one has to be always odd and one has to be always even. So this is the first thing to notice in this Sudoku variant. To get a prime sum, you can't have both even, because that would give an even digit, and you can't have both odd, again that would give an even digit. So using that idea, let us assume that this is an even, so which means that all the adjacent cells to that becomes odd and all the adjacent cells to the odd become even. So you can continue this trend, right? Keep on using this trend. All these cells which are one apart from each other would have to be odd and the rest of the cells become even. So you get a nice pattern with that. So this is the first thing to notice in the Sudoku, the first and the most important thing to notice in the Sudoku. And the next step that you can see in the Sudoku is you have now marked the parities. Now it's time to identify whether the greens are red. I'm sorry, that was a really comical statement to make. Whether the greens are even or the reds are even, right? So that is the next step to identify. So once we identify if the reds are even or odd, we can immediately write in the possibilities. So look at column 4, you can get the answer to that. So you have 3 greens here and 2 evens. So that must immediately prove to you that the greens cannot be even digits, because if the greens are even digits, then along column 4 you get a contradiction, right? Because there are 3 greens and 2 more evens, which is not possible, because in any row, column or box you can have only 4 evens and 5 odds. So which means that we are certain that the greens are even and the reds are odd. That's really nice now. So let us use that to solve the Sudoku. So this becomes odd and reds are even. So this is 2, 6. This would be 2, 4, 6, 2, 4, 8. That can be 2, 4, 6, 8. Right? And we'll continue using that to write all the even digits. Okay. So we got until here. Now maybe we can use the parity part a little bit and highlight some more cells. So we have got 4 evens along row 5, right? So rest of the cells would have to be odd, and 4 evens along column 5, so rest of the cells are odd. And we can even highlight the givens as odd, right? All these givens are odd, and there are some even givens too, so we can highlight them using red. All these are red, right? Okay, so let's write in some possibilities now. So this cannot be 1, this cannot be 9, so this would be 357, and this would be 359, because you have 1 and 7 here, so that becomes 359. And that has to be 379. This is even, so this would be 246. And you can mark the rest of the cells along row 3 as odd, right? We have 4 evens, 4 reds, so all these cells are odd. And now we have a really beautiful deduction in the Sudoku, guys. Look at this, these two cells. We have 3 reds and 4 greens, which means one of this is odd and one of this is even. And if you look at the even digit, it cannot be a 2, it cannot be an 8, it cannot be a 4, which means that the even digit present here has to be a 6. Really nice, right? So 6 goes here, which means this would have to be a 4. And that gives us the break into the Sudoku, guys. A really nice Sudoku. So this is not 4, that's not 4, and you have a 2-6 pair, so this becomes 8, and that would have to be a 4, which means this is a 2-8 and that is a 2-6. So you have a 2-6 pair, which means this becomes an 8. And now maybe we can look at this cell because it's heavily constrained. It's between two even digits. Let us see what are the possibilities here. Can it be of 1? 4 plus 1 is 5, which is prime number. 8 plus 1 is 9, which is not a prime number. So 1 is eliminated. Can you have a 3? 11 and 7. Yes, it's possible. Can you have a 5? 4 plus 5 is 9. Not possible. Can you have a 7? 8 plus 7 is 15. Not possible. 4 plus 9, 8 plus 9. Okay, 3 and 9 are the only possibilities which can go here. They become prime regardless of whether they are going with 4 or 8. And if you look at this cell, it can't be 5, it cannot be 9, it cannot be 7. So this becomes 1 and 3, and 8 plus 1 is 9. So this becomes a 3. That's nice. So 3 plus 6 is not possible. So that's not a 6. Sorry, has to be a 2, 4. And this becomes 1 and 7. Can't be 3, 9 and 5. So that's 1 and 7. And that would be 1, 5, 7. And it is along the line. So 8 plus 1 is ruled out. 9 is not a prime number. So 5 and 7. 8 plus 7 is also ruled out because it becomes a multiple of 5. So that has to be a 5. 8 plus 5 is 13. Right? And now let us see. This would be a 1, 3, 7 for the column. And if you look at this cell, it can only be 1, 5, 9. 1 is ruled out. So this is 5 or 9. 8 plus 5 is 13. 8 plus 9 is 17. So both are possible. Okay, so if you look at column 6, you'll notice that there are 5 greens. So which means these both would be red. They must be even. And now we have got 4 evens in box 8. So this must be odd. And now since these two cells are even, you can't have 2, you can't have 4. So they must be a 6, 8 pair. Which means this becomes a 2. That has to be a 6. That becomes a 2. And I think we can write some digits here now. So this would be 1, 3, 5, 7. 2 plus 7 is ruled out. 2 plus 1, 2 plus 3, 2 plus 5. All are possible. Okay. Okay. So these 4 cells must be 3, 5, 7, 9, right? But a 2 cannot go with a 7 because that gives a 9. So these must be 3, 5, 9. 2 cannot go with a 7. So I've eliminated 7 from these two cells. And 6 cannot go with a 3, right? So because 6 plus 3 is 9. 6 cannot go with a 9 because that gives you 15. So this becomes a 5. Really nice. So that is not a 5. That's a 3, 9. And now I can write some candidates. 3, 7, 9. And you have 1, 5 here. So that becomes 3, 7, 9. I have a 5 here, I have a 7 here, so this is 1, 3, 9, and this would be a 3, 9. You have 1 here, so that's a 3, 9. Okay, 6 cannot go with a 3. Am I missing something simple here? So I have 1 here, 7 here, 9 here, so this cell can only be 3 or 5. Okay, if you see something here, you have 2, 4 and 8, right? Okay, I was... Okay, 4 cannot go with the 5, guys. This is not a 5, 3 or a 9. Ah, I have a 3 here. Awesome. So I think we are going to resolve box 5 now quickly. So this becomes a 9. This becomes 5. That becomes 7. Now we get a 1, 3 pair here, right? So 1, 7, 9. So this becomes a 3. Can't be 7 or 9. So that would have to be a 3. And this becomes a 9. That becomes 3, 7. That has to be 1, 7. And only possible digit left in column 6 is a 5. I can place that. So I have 5, 9 here. So which means these 3 cells become 1, 3 and 7. So in column 9, I have 4 odd digits. Seems to be suddenly interesting. Okay, I have a 2 here, right? So which means this cannot be 2. That has to be a 6. And the moment I write that, I remember something that I did. So you have 2, 4 here, you have 6, 8 here. A 2, 4 here, a 6, 8 here. A 2, 4 here, a 6, 8 here. A 2, 4 here, a 6, 8 here. So basically these 4 cells have to be odd, right? This and this can't be even, so they become odd. Okay, so look at this 5. You can't have a 4 here. This becomes 2, 6. And you can't have a 6 here. 9 plus 6 is 15, so that's not a 6. And now you get a 2, 4 pair, which means this becomes a 6. And now 6 cannot go with a 3, so this becomes 1 and 7. Look how the Sudoku is imploding itself, guys. The moment we eliminate one candidate, the other candidate gets eliminated, and it's slowly imploding, right? An excellent construction. So 3 was eliminated from here. Okay, so I have 7 in row 4, row 6, so that's a 7. And these 3 cells must be 1, 2, 4 for the box. And for the row, these must be 1, 2, 4. And because you have a 6 here, they must be 2, 4, 8. And how did this become a 4? I don't have any idea. So let us look at this cell because it's adjacent to a given digit or a placed digit, I mean. So this is 2, 4, 6, 8. And you can't have 7 going with the 8. You can't have 7 going with the 2. So this is 4 or 6. It can be 11 or 13. There is no problem with that. Can we get something more here? I don't remember what I did at this point. Okay, let me write something here maybe. So this is 2, 4, 6, 8. 3 cannot go with the 6. Can go with the 2, can go with the 4, can go with the 8. Okay, there's nothing there. Okay, this is a simple miss, guys. 6 plus 3 is 9. So you can't have a 3 in row 6 column 9. So that becomes a 5. And that should give us something. Okay, let's look at this. This is 2, 4, 6, 8. Cannot be 5 plus 4. So that's 2, 6, 8. Can it be 6? Can it be 8? Can it be 2? Yes, all are possible. Because 5 with all of those digits are giving us prime possibilities. And because of this 1, this is not a 1, that's a 3, 7. This is not a 1, that's a 2, 4. 6 cannot go with the 3. That is not a 3. 6 cannot go with the 9. That becomes a 15. So that's a 1. Superb. So that becomes 3. That becomes 1. This becomes a 2, 4 pair. That becomes a 1. That becomes a 2, 4 pair. This would have to be a 9 cannot go here. So this has to be a 3. That would be a 9. And now we are getting some action. So this 3 gives a 7 here, which in turn gives a 1 here. So this becomes a 6, 7 pair for the box. There is no 7 here, so that's a 3, 9. And because this is odd, so this would be 5, 9. Okay, so because you have 1 here, this cannot be 8. That becomes 2, 4. And this 1 removes the 1 from here, so that becomes 3, 7. Okay, so it was at this point I think I got stuck on my first try, guys. There is a really sharp deduction at this point. So if any of you guys have patiently watched until this moment, I would sincerely request you to show me some other deduction other than the one that I'm going to show you now at this very point, because I quite well remember that at this point I didn't see anything else. Yes. So at this moment, I'm going to show you guys a deduction, and I want you guys to find a deduction which I didn't use to continue the Sudoku. So basically I deduced that this cannot be a 7. So if this is a 7, look what happens. You can't have a 2 here because 7 plus 2 is 9, not possible. So that becomes 4. And using classic, you have two 7s here, so that would be a 7. And because of that 4, you get a 6 here. And now look what can go here. It cannot be a 6 because you have 6 here. It cannot be 2 and 8 because 7 plus 2 is 9 and 7 plus 8 is 15, both of which are non-prime. So this was the, you can say, ultra sharp deduction that I used, and which took me quite a while to continue at this point. So I would really request you, dear viewers, to show me something at this point which did not involve deducing that this cell cannot be a 7. So if you guys can show me something else at this point, I would really be fascinated to know that. So this is not a 7. This would have to be a 3. We just saw what happens if this is a 7. So the moment we get this as a 3, using classic, 3 goes here. And now 7 in box 7 is going into one of these 3 cells because it just got eliminated from here, and that 7 gives me a 1 here. So which means this would be a 3-7 pair, and now this becomes a 1-5-9. And 7 in this box goes here. And a bit of classic will show you that these 2 cells must be 6, 8 and 9. Just writing the candidates there. You have a 2-4 pair. So of course I can shade these 2 cells as even. These would be even. So you have a 2-4 pair here and 3-5-7 here, which means that these must be 1, 6, 8, 9, but both of those cells are not 1, so they must be 6, 8 and 9. Okay, this must be a 5, 7, 9 because that is odd, so that becomes a 5, 7 and 9. Now if you look carefully at these 2 cells and ask yourself whether they can be odd, you will very soon realize that they cannot be odd, because I have 1, 5, 9 here and a 3, 7 pair marked in logged in box 3, which means none of these 2 cells can be odd digits, so they both become even, which means this becomes odd. So this is can't be 3, 7, so this must be 1, 5, 9, and both 1 and 5 are eliminated, so that becomes a 9, that becomes a 5, and that becomes a 1. So 9 eliminates the 9 from here, becomes 3, 7, so 3, 7 pair, and 6, 8 and 1 and 9, so these becomes 2, 4, 5. And using classic you can eliminate 2, 4, or by seeing the green color you can straight away place the 5. So that's a 2, 4, that's not a 5, that's a 7, 9. Okay, because of this 5, this cannot be a 4 because that gives you 9, not possible, so this is 2, and that has to be 8, can't be 2 or 4. So these become now 4, 6, 9 for the column, and that gives you a 2 here. That's not a 2 or a 6 because 4, 6, 9, so this is 8, and that would be a 3, 7 pair for the box 3, 7, right? 1, 2, 5, 8, 4, 6, 9, 3, 7. So this is a 3, which means that becomes 7, that becomes 3, that becomes 7, that becomes 3, and that would be a 4, 6 pair because of this 4, that can be resolved, 4, 6 pair. Okay, 3 cannot go with the 6, so this would be a 4, that becomes 2 using classic, and 7 here gives you a 9 here, and using classic 1s here give you a 1 here. So this is not a 4 or a 9, so that is a 6, and that becomes 8, that becomes 6, that becomes 9, that resolves this 9-3 pair, 3 6 7 1 2 9. So this must be a 4 or 8, and you have 6 9 here, so that would be 8, gives you a 4. And we can tidy up the place. 2 3 4 1 8 9, so this would be a 5, this is a 6 and 7. Because of this 6 you get a 6 7 here, and you get a 9 in column 1, right? So we are close to completing the Sudoku now. So because of this 6 you get a 6 and a 7. This 4 resolves this 2 4 pair. So 3 5 9 1 and 6. So okay, 1 3 5 6 4 8 9. So these would be a 2 7 pair. That becomes a 4 now. That becomes 4. That becomes 2. This 2 resolves this 7 2. That becomes 8. And with that we have completed this really gorgeous construction by Lavaloid. The most important thing to realize in the Sudoku was that to get a prime sum from adjacent cells, one has to be odd and one has to be even, and that allowed us to give red and green all over the grid. And we got to deduce that reds are even by noticing that there are 3 greens in column 4 and 4 and 8 even digits, which made us to realize that greens cannot be even. And then there was one breakthrough reduction involving this 7. You have to deduce that that cell is not a 7 to continue the Sudoku, because I really suffered in my first attempt. Without that deduction, I'm pretty certain that there is no other continuation. So I asked you guys the question, so you can let me know if there was something there. Thank you guys for watching. We really hope that you enjoyed this video. Please do hit the subscribe button below, and we hope to see you soon. Bye bye.